Good day everyone, my name is Obi Promise. I am a student from Uniform Schools, which is located in the Ikorodu local government area. And I am here to talk to you on the overview of our robots. Actually, there are different kinds of robots, but we decided to build the humanoid kind. It is called humanoid because it has the same feature of a human being. As you can see, the leg, ankles, and the feet. And the features of this humanoid and the raw materials that we used to create it. We use straw boards, DC motors for the feet. As you can see, there's an L298N motor controller, batteries and their cases, microcontrollers, jumper wires for their connections, and there's also a straw here to pass the jumper wire so that they can be up here, and a rope for the stamina of the robot.
My name is Dairo Abarami Ogulwa. Today I'll be talking to you on the ankles and joints of the robot. As you can see here, the ankles and the joints are used to aid free movement so as to avoid the ripping and tearing of the robot. It also helps to make sure that the robot does not rip apart and in any way through the movement.
Good day everyone, my name is Izidino Angel. Today I'll be talking about a humanoid robot's leg. This humanoid robot leg are made up of straw boards, glue gun and 2 DC motors with a table to measure the measurement of the straw board. First, we had to measure the length of the straw board 15 by 11, which we cut out 6 pieces of the straw board to make the leg thick enough in order for the legs to carry, because the legs carry the weight of the robot. 2, we use a glue gun to put together the 6 cut out parts of the straw board. And after using that, we also put together the 2 DC motors with the use of a glue gun. This is a humanoid robot which has the 6 cut out parts of the straw board which are put together by this glue gun.
I'm here to talk on the circuitry of our robot. First, we're going to talk about all the materials needed in order for all the circuitry you are seeing here. First materials are the DC motor, a couple of jumper wires, male and female, and a couple of battery with the battery pack, our microcontroller, and the L298 motor driver. In order for all, we're here to put the circuitry together. So we're going to first start with the L298 motor driver. The first part we're thinking of now is the R1, R2, R3, and R4, which we all know. R1 is the nose and the positive side of the L298 driver, R3 is positive, R2 and R4 are also negative. In order for us to connect this, we have to first take our battery, test them with the DC motor in order for us to know the positive side. The positive side of your DC motor goes to your R1, which is positive, and the negative side goes to your R2, which is negative. After doing the R1, R2, R3, and R4, then we move on to our ENA, ENB pins. ENA also stands for enable pins. The ENA will be connected to the PWM pins on our digital part of the microcontrollers. The PWM, also known as pulse width modulation, and the other outputs here will be connected to any other pins on the digital section of our microcontroller. And we also have this area over here, which has 12 volts GND and 5 volts. The 12 volts, which will need our battery pack in order for us to connect this. The positive area of the battery pack will move to your 12 volts over here, and the negative area will move to your GND over here. And note, 2 pins will have to be located in the GND, so we'll take our male and female jumper wire, connect it to the GND part with also the battery pack negative wire in the GND. So this jumper wire will go to the microcontroller's GND over here, the microcontroller's GND, and don't let us forget the 5 volts, which we also use another jumper wire to connect it to our microcontroller at the VIN, which is also known as voltage inputs. So after all that is done, we'll have to put our batteries into the battery packs, and once all that is done, the microcontroller should light up and then we put our codes.
So we want to turn on the robot now to see it in action.